Hello everyone, welcome to POESI's e-learning and certification services. This is a supplementary session in the Internet of Intelligent Things series to share more information about microcontrollers and their selection criteria. Selection of the right microcontroller is most crucial for the success of an IoIT product. The key factors to consider to make the right decision are processing speed, measured in terms of operating or clock frequency. A faster microcontroller offers better performance. Second measure of processing speed is number of instructions executed by microcontroller in 1 second, often mentioned in MIPS or MIPS. That stands for million instructions per second. Second parameter is architecture. Data bus width signifies the amount of data fetched from memory in one go. Wider the bus width, better the performance. CISC or RISC stands for Complex Instruction Set Computers and Reduced Instruction Set Computers. RISC architecture is preferred because of better performance and energy efficiency. Single or multi-core signifies number of processors fabricated on chip and working together. A multi-core architecture obviously offers better performance. Power consumption is another critical factor since most of the smart products use battery as primary source of power. Power efficiency determines battery lifetime. A trade-off exists between power consumption and performance. As the performance goes up, so does power consumption. So it is not always good to go for faster computers. Availability of memory also matters. Application programs, operating system, and data reside in memory. There should be enough memory to accommodate them. Availability of digital and analog general purpose input-outputs, wired and wireless interfaces determine uninterrupted seamless flow of information in and out of the product and also determine its interoperability. Security being one of the greatest concern of end user need to be addressed from the design phase itself. Microcontroller with code lock, tamper-proof, secure boot, secure execution zone, and cryptographic acceleration are preferred. Form factor, package type, cost, availability of programming and testing tool, and availability of development kits. These are other factors that need to be considered. I have selected 3 microcontrollers from 3 most popular microcontroller families as an example. The first microcontroller is from AVR family. AVR is a family of microcontrollers developed since 1996 by Atmel, acquired by Microchip Technology in 2016. These are modified Harvard architecture 8-bit RISC single-chip microcontrollers. Let us look at one of the popular MCU from this family, ATmega2560. The high-performance, low-power microchip 8-bit AVR RISC-based microcontroller combines 256 kilobyte ISP flash memory, 8 kilobyte SRAM, 4 KB EEPROM, 86 general-purpose I/O lines, 32 general-purpose working registers, real-time counter, 6 flexible timer counters with compare modes, PWM, that stands for pulse width modulation, 4 UARTs, also supports UART communication, byte-oriented 2-wire serial interface, 16-channel 10-bit A to D converter, and a JTAG interface for on-chip debugging. All of this fabricated on a single chip. The device achieves a throughput of 16 MIPS at 16 MHz and operates between 4.5 to 5.5 volts. The second example of a microcontroller chip is from ESP family. Espressif ESP32S3 is a dual-core Extensa LX7 MCU capable of running at 240 MHz. Apart from its 512 KB of internal SRAM, it also comes with integrated 2.4 GHz 802.11 version BGN Wi-Fi protocol and Bluetooth Low Energy 5.0 connectivity that provides long-range support. It has 44 programmable GPIOs and supports a rich set of peripherals. Compared with ESP32, it supports larger, high-speed octal SPI flash and PS RAM with configuration data and instruction cache. ESP32S3 provides all the necessary security requirements for building securely connected devices without requiring any external components. It supports AES XTS based flash encryption and RSA based secure boot. In addition, ESP32S3 has a digital signature peripheral and an HMAC module which provide functionality that is similar to the hardware secure element, thus protecting the private and symmetric key from software attacks and identity theft. The third example is CC3220SF, a microcontroller from TI SimpleLink wireless family. SimpleLink Wi-Fi wireless microcontrollers enable cloud connectivity with features including 2 separate execution environments, a user-defined dedicated ARM Cortex M4 80 MHz MCU, and a network processor MCU to run all Wi-Fi and Internet logical layers. 30 plus security enablers with WPA3 and FIPS 142 standard support. Advanced low power modes, interoperability tested with 200 plus access points, rich set of IoT security features. These features make CC3220SF one of the most popular microcontroller to build IoIT products. I hope you found the information shared in this session useful. In the forthcoming sessions, we are going to learn how to build applications to be deployed on these microcontrollers and build IoIT products. So stay tuned, stay in touch, happy learning.